Here we go. So I'm just going to talk a little bit about our vision and where we're going. I think most people know of MEF as Carrier Ethernet, and that's fine. That's really our background. But I think you'll see that where we're going is really embracing where the industry is moving to, and we're supplying some really tangible solutions. The other thing I'm going to cover, because it's automation, I want to really cover about the APIs. And I'm going to go much, much more deeper than the workshop about APIs, and it was a great presentation on Legato. But I'm going to talk about model-driven APIs and even get into the details of the tool chain. So I think this should be quite more detailed of explanation around these APIs. Hopefully you'll like that. And finally, I'm going to talk about AI and machine learning and analytics and the projects we're working in that area, because I think it all kind of feeds back in eventually into this whole idea of automation. So let me just start. I'm not going to spend a lot of time, but basically MEF's been the sole authority that has driven this Carrier Ethernet market. Started in 2001. I was a co-founder of the MEF. I left 6 months later, did a ton of startups, worked for Microsoft for a decade, came back, and now I love the network transformation happening in the industry, so really want to be involved in that. And as a result, MEF has done an amazing job driving Carrier Ethernet to 80 billion products and services and going north to 100+ billion. What we are doing, though, is we're taking that momentum and we're really building upon a whole new strategy and vision, and you're already seeing that starting to come to fruition with the Verizon Colt announcement of Sonata East-West. AT&T and Orange also showed some examples, and then also you saw also Legato. What you're seeing in the industry is exactly what's happening is everything's digitizing, all the workflows that we understand, including today even my daughter will not even watch it on TV or cable, she'll watch Netflix. Everything is digitizing, and it's just the way life is. And so with that, we need a modernization network. So really what we've realized within the MEF, it's coming back to three major things we're seeing. And I talked to many providers. We have 130+ service providers just in our membership. And they range from tier 1s to tier 2s and even tier 3s. And they all have the same goals. They want to be cloud-like. They want to have automation, which is really what this is all about, this conference. And then finally, they want to interconnect their networks together. And so these are the three main principles they're trying to achieve. Of course, there are other subtleties to this, but these are the three main concepts. So we've embraced these three major points to what our members want, and we've come up with a vision that basically looks like this. As you know from the last speaker, we've been defining MEF Lifecycle Service Orchestrator for a couple of years, and I'll talk about that framework in a couple of slides as we drill down deeper. But that's a key point. It provides that automation. As you can see, it's a self-service portal, just like the cloud guys have it. You can provision the tenant can provision what they want as a service, as high-level business rules, and then finally, that should just get plumbed down through automation from orchestrators, lifecycle service orchestrators, to the various parts of the networks, including SDN controllers, NFV manos, including other resource orchestrators that are responsible for their own little domain. And then the goal is to have the end-to-end service run when that subscriber puts in the portal. It should just work through the network, but also between operators. And this is what we were talked about. Verizon talked about their Sonata East-West stuff for Carrier Ethernet. The ultimate goal is that the same system should be able to carry any products, any services, whether it be optical, Carrier Ethernet, IP, SD-WAN, security as a service, whatever telecom comes up with, it should be able to provision. This is really how the cloud guys done it. And I spent a decade at Microsoft, so I really got a great understanding of what it means to be cloud-like, and it was a great blessing and great learning, and I'm really appreciative for that. And now I'm seeing that the industry, the telecom industry, is moving, embracing the same approach. So as you can see in our vision, connecting to clouds are important, connecting to sites, having interconnection between providers are very important. All of this has to be driven by machines and not people, because you've heard many, many presentations how mistakes are made. It's time, the agility, the service velocity, and important, a single fabric to multiple services. So what we're talking about at the MEF is we've really had this ability in the last, I think, 2001 to 15+ years to really describe a service from how a subscriber would buy it. And it's just a standard language that everybody can talk. And it's describing that service. And between providers, we describe that service. So we call it subscriber or provider for carrier Ethernet. And what we've now done is we've looked at that rigor and that discipline, and now we're applying it to other services. So you'll see shortly coming out, optical will be announced this year. We'll have an optical service definition. We're already building an IP service definition, and by the end of the year, we will have also SD-WAN come out as a service definition. So that means a subscriber would buy a managed SD-WAN service from the service providers or a managed service provider, MSP, and basically they would know what they're getting. Long term, we want to be able to add other services to this multi-service kind of idea platform. And so we're looking at security and applications and all that, but that's kind of longer term, so I won't spend a lot of energy there. But the first four you see here, this is coming out this year. Now, when we talk about this, real important is about how do you orchestrate this, because having static services is not the wave of today. It's what everybody wants is an automated, orchestrated way of doing this where it's all done through a portal. So what we've done is in the MEF is we're now moved into a whole new way, and we've launched this framework called MEF 3.0. And I'll talk about just one of the details, the APIs, because that's all we have time for. But really, we are helping our members on this transformational journey. And as you can see from the very left, the very static model of yesterday, and a lot of members are still caught in this area, but we really want to get to this automated model of orchestrators and doing multi-services, and to this final part, which I'll talk about, machine learning and analytics, where the networks are self-healing, self-optimizing, and really people are completely out of the loop, including alarms coming in from a service OEM. It doesn't go to help desk anymore. Machines take care of it and optimize and corrects the network and resources. So I'll talk about that at the end of the presentation. So this is basically our framework. It was launched in November at MEF 17, our big annual conference. And it comes in 4 parts, and I won't have time to cover all of it. So the main one I talked about is services, carrier Ethernet today, coming out this year, IP services, SD-WAN, and shouldn't say optical, it's layer 1 services. The next one is basically the LSO framework and APIs, which I'll go into details here in a second, and we'll drill into that. And then finally, we've changed our certification, which I won't have time to cover, but it's all cloud-based, it's real-time. As the APIs are changing, as the products and services are coming online, the certification just automatically happens from the cloud. It's a cloud-based certification. We'll not have time to cover that. And then finally, we have this community, and we've really changed the way we've done MEF. We've moved into this very agile approach, and this is why we deliver APIs in less than 3 to 6 months. In fact, Sonata was like 6 months from the very first, and we delivered the first release, and that was the first time ever doing it. Now we can do it even faster, every 3 months. And we also have this ability to have this private cloud where we actually incubate a lot of areas. Sonata came from the incubation in the community area. It was not coming from the committees. It was incubated there with a bunch of members and their developers. We're developing code. We're doing reference implementations. We have SDKs, completely different than a standard SDO that you normally think about. We are both, spec-driven and also showing code. Not open source. We're working with open source, but showing the code as referenced implementation. So that's the big takeaway in communities. So let me drill into this API. What is this API? Why is this so important if we go into automation? The first thing you see is if I can get this to work right. Okay, I know I'm doing this right. It's not working. Oh, there it is. Okay, so the first thing you see is this is our framework. This was launched a couple of years ago, got approved. It's called MEF 55. And what it talks about is basically these different reference points. And you saw in this last presentation, legato. You see right here, this is between the BSS layer and the OSS layer, if you want, the orchestrator itself, and the BSS system, or the business system. And that's the legato that was talked about. But then below that, we released Presto, which talks to the SDN controllers. In the last presentation, it was kind of proprietary APIs, but we actually have an API for service fulfillment on this Presto reference point that talks to an SDN controller that then activates an E-line service end-to-end. And we have that actually released, and in our SDN controller or the NFV Mano and all the things below it that we don't really care about, other bodies are taking care of. So we just call it a reference point, but this is the netconf and the OpenFlow and all the other stuff. CLIs belong there. So we don't really get involved with that. That's all below the SDN controller or the Mano, inside the Mano. Okay? So think of, so this is the key point is our reference architecture. And the other key point is we describe these key areas of capabilities that we believe an LSO should do. And again, the goal of an LSO, lifecycle service orchestration, is to open and provide a service through a portal from one uni endpoint to some other uni endpoint, wherever that might be, or multiple points. And it should be all done orchestrated, regardless of the technology domains it goes through. So, or providers. Okay, so this is the key point you want to remember, because we're going to start drilling in now into specific areas of the API and how we develop these APIs so fast. In fact, this is becoming the industry model of how APIs are going to get generated. Okay, maybe I should just do it. So again, we talked about these. We did the framework, and we did it in this very agile approach, 3 to 6 month sprints. I talked about some of this. So here you go. Here you see that we have on this Sonata reference point, these 5 use cases that have already been come out in experimental mode and soon will be released into what we call publish mode. And we'll talk more in detail as what's the difference. And as you can see, this was done really, really fast. And this is what you've been seeing all the noise about in the press and so on, how they can get quotes and check for addresses, all machine to machine, all from a single portal, and it's talking between providers. So that's an example. What you're also seeing here in the same Sonata, look at what's going on of all these other use cases we're delivering on. So in release 1, in the first, in 2017, I don't remember what year that was, what month that was. That was Q4, I think. We delivered the Sonata, this release 1, and you can see the serviceability has, even the serviceability use case has more and more operational threads that describe further what, the details. And as you can see, as we're releasing more, release 2 just came out, and you can see that we're adding on to these use cases more and more. So in our agile approach, every 3 months, we're delivering more and more. And this is just Sonata. This is just one reference point with all these APIs involved on all these use cases. So now, how did we do this? How did we do this so fast? And how come this can happen so fast when in the old days, it takes a very long time, it's handcrafted APIs? And here's the secret. We've gone to a model-driven approach. A model-driven approach means that we don't describe APIs and we don't do them handcrafted, and we don't describe the APIs in data models. We describe them, first of all, by describing information models and describe the use case and operational threads and what we want from the API. Then we model them in UML, which is a standard modeling language most application developers know. And then we generate the UML and we run it through another tooling, and I'll show you that tooling, that then generates the data models, and that could be Yang, that could be a JSON, that could be in Tosca, it could be in any data model. And the next slide, we'll get into a bunch of details. And then finally, that hits the Swagger, the tool sets and tool chain, which they can render out APIs into any language. So what that looks like in detail is this slide right here shows you the exact actual detail. These are all open source platforms, but you can see that if you model your API in UML, you get the file, you can render it out through a tooling, open source tooling called Eagle, and that can then generate the docs and also generate it in different data models. So Yang and JSON today, Tosca tomorrow, we're working on that with the open source community. But the nice thing is, once it complies to this open API spec, then basically, and it's a open API organization forum that does this. Once you comply to this, Then the Swagger tooling just kicks in, and basically you can do Swagger code gen and write that to any programming language you want. So basically, what you get is, if you get the model from the standards and you model it in this editor in UML, you hit the button and out comes your code in exactly the language you want in client-server stub code, and then you can test it and all the other stuff with Swagger. So this is really, really powerful. And so from a developer, you get client-server stub code, and then you can add your logic to it. So basically, what we have to do is, today, these are all in pieces, and what we're trying to do now is make an IDE, an integrated development environment, where literally from the point you get the models, you push the button, the IDE generates all the artifacts that's needed, including software documentation. So it looks like this. The IDE generates all these various artifacts, including sample code and all this kind of documentation. And so the developer's life of building these APIs becomes so much more easier. So this is how we generated the Sonata work and the Presto work. We used some of this tooling. Now, we had to still handcraft and stitch some of the tooling together because they're not integrated like this slide I showed you before on the IDE, but we're working to make that very seamless and very easy to use. So if you go to our site and you're a member, you can actually download, this is released an SDK. It has a lot of the ODL stub code to be able to run Unimanager to do, I talked about the provisioning from ODL, all the way from Legato, right down to Presto, which will then provision E-line on an ODL controller. That's actually working, and you can get that in the SDK. And in Sonata, you can get some of the things I talked about in an SDK. I only got 2 minutes. I won't have time to really get into this, but catch me at the reception. I can talk more. So I'm going to move on because I've only got a few more minutes, but I want to cover something that I think is even more emerging. And as I talked about, we are incubating many things at MEF. We're not just sitting and writing paper. In many areas, in fact, we have 12 implementation projects that are not even have specs yet that we're working on, like security as a service. One of them is AI, ML, and analytics. And how do we do closed loop automation, right? And so this is actually proven out in real projects going on inside our private cloud with our members pulling together on this. So here's an example. We've loaded in a Panda database, and that's from Linux Foundation. It's a big database, and we collected lots of network telemetry data from real networks. We have 3 member companies providing these telemetry data, and this could be netconf, NetFlow information, whatever information. It comes in various ways. It comes up and sends up the telemetry data into a data lake platform. The data lake platform then stores all these random data, and then what we have is we can have network events of like queuing overflows or class overflows. We can have soft events, like, for example, a service OAM is getting an event, where it's getting too much jitter or packet loss coming from the orchestrator, because in Ethernet we have a service OAM that's always running inside between unis or NIs, and then finally we can even have cloud applications send telemetry data, and then we have AI machine analytics application that takes the events and does a specific use case, and that's really the power. So we're actually showing some of these areas, including applications feeding in analytics, telemetry, and events to have AI analytic applications do something. So these are in our implementation projects and working with our members and universities in our part of our MEF developer community. We're showing and working on these areas. So here are some really fast areas. They're showing you how to do this. I was in the Skype for Business group. I actually pioneered a lot of these ideas where the Skype application was sending real data to analytics so that it could do something and program the network. You can have today DPI engines like in SD-WAN networks. They use DPIs. Cisco NBAR v2 is an example. All these DPI engines of SD-WANs are now, and you can send to a proxy and it can send information. Or you can do synthetics like Service OAM or any kind of application synthetics you want to do, like what SD-WAN guys are doing also. And that can then also trigger. So these kind of models are very much can be used. And what you can then do is, if you look at what SD-WAN's doing, it's really powerful. It's taking these constructs of SD-WAN, taking application awareness, they're already adding in security into it, right here, and can add in other virtual functions. And now what you get is the ability of orchestrating all these services and getting that awareness of all these services pool into that big data lake and having AI analytics applications really do something powerful. So at the end, what you get is this idea of overlay networks start to emerge with SD-WAN driving it and all the virtualized services. And then finally, you get into the idea of having even east-west to control the underlays even, for example, broadband loops, MPLS loops, and not just carry Ethernet. So this is the power of when you use APIs and automation and LSO, you get the ability to get true automation and true closed-loop automation and closed-loop assurance and closed-loop analytics. Okay, so that's the key point. If you want to get involved, anybody can attend as an audit member into our next meeting here is in Athens. This date, just reach out to me, and I can hook you up for free to come in and be an audit member for one time and see all the works we're doing. And finally, we have our MEF 18 event once a year. It's 1,000+ people, and you get to see a ton of this kind of stuff and people talking about it. Okay? So thank you. I ran out of time. And thank you very much.